Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math YouTube channel. Make sure you like this video. Make sure you drop a comment down below. And make sure you share this video with at least one other person. At least one other person. And have them share this video with at least one other person. And keep it going and going and going. All right, so what we're about to get into. All right, so we're about to find the LCM, which stands for least common multiple. Least common multiple of some variable expressions, So this is something that you might see in an Algebra 1 class. Maybe if you're lucky, you'll see it in a pre-algebra class, right? Hopefully you're seeing it in middle school. If you're not seeing it in middle school, you're definitely going to see it in a high school Algebra 1 class. All right, so how do you find the LCM? It's two things you got to look at. You got to identify the coefficient of the term, and then you got to identify all the variables in that term. All right, so your coefficient and then the variables. So let's take a look at number one. First of all, what are the coefficients of those terms? First of all, what is a coefficient? The coefficient is basically, it tells you how many of the variable you have, or how many of the variable term you have. All right. And number two, 4 is the coefficient. This tells us that there are 4 A's. Here, 12 is the coefficient. This tells us that there are 12 A's. Here in number 3, this 3 is a coefficient. It tells us that there are 3 x squared terms. This 6 tells us that there are 6 x to the 5th terms. All right. Now, what happens if there's no number written? This is something you got to learn if you don't already know it. If there's no number written, think to yourself, what's understood don't need to be said. Or what's understood don't need to be written. If there's ever no number written to the left of the variable, it's understood to be a positive 1. It's understood to be a positive 1. So that means this could be read as 1x to the 3rd. Because that's how many x to the 3rds there are there. This could be read as 1x to the 4th, because that's how many x to the 4ths there are there, right? So it's one of these and one of these, all right? Now, when we're trying to find the LCM, you want to first find the LCM of the coefficients. Then you want to find the LCM of the variable expressions. So you want to do this like in a systematic way, right? And no matter how long and complex the variable expression is, you want to follow this method. Because sometimes you're going to see terms that's got like 3 or 4 different variables in it, but you're still going to follow the same exact protocol, the same exact process, right? Deal with the coefficients first, then deal with each of the variables. Deal with the coefficient first, then deal with each of the variables. So, all right. So out of 1 and 1, what's the least common multiple of 1 and 1? Exactly. It's 1. It's going to be 1. So I'm going to write a 1, right? Even though in my final answer, I don't need to have the 1 for a coefficient written, but I'm just showing my steps. All right. Now go to the variables. Now, again, what is a LCM? What is a least common multiple? All right. A least common multiple it's the smallest term, right, that both of those numbers or variables in this case can multiply into. The smallest variable that both of them can multiply into. X to the 3rd can multiply into x to the 4th, and x to the 4th can multiply into x to the 4th. So x to the 4th is the LCM. So we're going to write this next to the 1, and that's 1x to the 4th. Then I'm going to simplify that, and I'm going to just call it x to the 4th power, which is going to be our answer for number 1. Another way to do this, though, right, this x to the 4th part is basically the opposite of how you find a GCF, which stands for greatest common factor. It's the opposite, right? With a GCF, you look for the variable they have in common, and then you take the one that's got the smaller exponent. So if I was looking, if I was looking for the GCF for these two, it would be x to the 3rd, because 3 is less than 4. But when you're looking for the LCM, you take the variable that's got the bigger exponent, the bigger exponent. One more time, the bigger exponent, right? So it's going to be x to the 4th. All right. Now, again, what is an LCM? It's a term that can be multiplied into by both of the terms under consideration. So I could do x to the 3rd times, watch this, x to the 3rd times x, which equals x to the 4th because of the multiplication property of exponents. This has an invisible exponent of 1. 3 plus 1, when you multiply, you add the exponents. When you multiply, you add the exponents. So that's going to be x to the 4th power. I could do x to the 4th times 1, which is just x to the 4th, to get x to the 4th. That's why x to the 4th is the LCM of those two variables. All right, so we follow it. So understand and stay consistent with the rules for what an LCM is. Now let's go to number 2. We got 4a and 12a, right? So 4a and 12a. So check the coefficients, 4 and 12. Those are the coefficients, 4 and 12. So what's the smallest number that both of them can multiply into? Don't confuse multiples with factors. Don't confuse multiples with factors. Do not confuse multiples with factors. 4 times 3 is 12. 12 times 1 is 12. 4 times 3 is 12. 12 times 1 is 12. 12 is the smallest number that they both multiply into. So 12 is going to go right here. Then we look at the variables. We got an a and we got another a. What exponents do they have? If you don't see no exponent written, that means the exponent is a 1. It's a 1. It doesn't need to be written, right? So if you compare the exponents, which exponent is bigger? What's bigger, 1 or 1? Neither. They the same number. So you just pick a to the first power because they the same number. And that's your answer, 12a, right? You got 12a. Then for number 3, we compare the coefficients. You got a 3 and you got a 6. You got a 3 and you got a 6. 3 times 2 is 6. 6 times 1 is 6. 3 times 2 is 6. 6 times 1 is 6. 6 is the least common multiple of the 3 and the 6. So you put the 6 right here, and then you compare your x terms. The x that has the bigger exponent is x to the 5th power. X to the 5th power. So that's your part of your LCM. So it's going to be 6x to the 5th power. And also keep this in mind too. I know this is good because x to the 2nd times x to the 3rd. Again, remember the multiplication property for exponents. When you multiply variables, you add their exponents. So that's going to be x to the 2 plus 3 power, which is x to the 5th. And then x to the 5th times 1 is going to be x to the 5th. So since they both x to the 5th, x to the 5th is the LCM. All right. So just a little bit of algebra, dealing with least common multiples. But remember, when you're dealing with variables, one of the most important things I want you to take away from this is the difference between finding an LCM versus finding a GCF. When you find an LCM, you look for the bigger exponent. When you find a GCF, you look for the smaller exponent. GCF, smaller, it's kind of counterintuitive what they said. I like that word, counterintuitive, because you would think, well, why am I finding the bigger exponent if it's the least common multiple? But then for the greatest common factor, I'm looking for the smaller exponent. All right. I'm going to get into that and explain all that in another video. But just keep that in mind. For now, just memorize that. But also for the LCM, understand the process and the concept behind it. Like, why was x to the 5th the LCM? Because x squared times x to the 3rd gives you x to the 5th, and x to the 5th times 1 gives you x to the 5th. All right. So, yeah. But all right, stay locked in. I'll see you on the next video.